Interesting. Have you guys got back your assignment feedback? Have a look? Not yet. Huh? Yeah, can you have a look first, and then also I posted out the solution already. How's the preparation? Midterm. Huh? Not yet finished. No, yet start. No, yet start. Better start now. After what? So it's enough. One page is enough. Like I got the practice exam, right? So make sure it's enough to answer those kind of questions, right? Uh, First of all the tests, and then the Fourier series formula, right? Trig, integral, right? Okay. Yeah. How about let us discuss assignment first? Let's discuss assignment first. You can pull out your assignment feedback, okay, and then try to compare what we have. You have a question? Yeah. Will the midterm as well? Difficult? I don't think so. Mm, Less than or equal to. Some hard, maybe some a bit tricky. I wouldn't say hard, but just tricky. Just tricky. Have you tried the practice exam? Not yet. No, I mean you should start now. You should start now. Start tonight. Otherwise, mathematics is like this. The first day I step into mathematics, okay, the things get very hard to digest. I wouldn't say hard, very hard to digest. 很难消化。怎么消化呢？你看一只蟒蛇啊，吃掉一只羊，比它大的羊，怎么消化呢？对，要时间。okay, do philosophy first. Okay, do philosophy first. But I mean, yeah, as quickly, do it as quickly as you can. How to say? Yeah, for new knowledge, right? Sometimes you need time to absorb it, digest it. Okay. It's not that you don't know sometimes, After you learn it for a period of time, then you realize that actually it's obvious. Okay. Yeah. 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 Actually, you think that's obvious, but you need to digest it. Okay. I mean, in mathematics, right? There are a lot of things to study. These are like 500 years knowledge, 1,000 year knowledge, 2,000 year knowledge, right? Squished into one semester, 15 weeks, right? Only 2 days. So it's hard. It's hard. Okay. And then mathematics, there's no hands-on. Like you need to go to lab. You need to do computer lab. You need to do lab work like chemistry, engineering, right? So what is the mathematics degree training? It trains your mind. It trains your mind. Okay, that's why you feel tired. No. If you feel tired, you are right. If you don't feel tired, there's something wrong. Something wrong. Okay. But remember to take a breath. Yeah. If you feel tired, it's correct. Because mathematics is training your mind. Okay. Okay. For first question, right? For assignment 2, first question. Talk about this irrationality of pi. So how to show pi is irrational. Okay. So the hint here uses the theory of series. Okay, series. Use series to prove it. Okay. So the purpose of this example, right? This question, I want you to construct a proof. Okay, I want you to write a proof A set. Okay. But a lot of you just write I solve A is what, B is what, C is what, D is what, and then finish. Okay. In future, I want you to like organize your idea through start from this proof here. Read my solution here. Okay, see how I organize the point into a proof. Okay. So please learn how to write a proof. Okay, how to organize ideas together. Okay, the hint help you to break down. Okay, break down the proof into points, and then I want you to combine the point. Okay, can get what I'm trying to say? Okay or not? Please learn how to organize idea into an essay. Okay, yeah, into a proof. Okay, yeah. In mathematics, you don't need to like English essay. Okay, like you don't need to put bombastic word. Okay, special word. Just that you need to organize your idea. Okay, then, since, therefore, so, because. Okay, just this connective word. You need to use it. Okay. Yeah. Uh, I think most of you do this okay, except maybe some of you. Yeah. Any question on this first question here when you do this question here? Any question you pop up in mind that you don't know how to solve? When you first see this question here, when you first do the question, maybe bothered by the infinite sum or what? Hmm? Do you get stuck on this question when you do this? Huh? Sorry? You just start on B and D. B and D. Huh? Yeah. B and D, yeah. Which part you think is not obvious? Like hard. Mm-hmm. Oh, you mean D, yeah, D. Part D, is it? D pi, you mean this pi, huh? Huh? The integral, this one? How to get this? Okay, okay. Yeah. Yeah, it's, oh, how to get this? Okay, good. Okay. Okay, I want to teach you how to read this maths statement here. Okay, you see, they ask you to show this inequality, right? Hence that meaning there's something before. Okay, something before is this, show that this is true first. And then hence that this is true. So meaning this result, the integral result here, come from the result just before this. So you need to think a way to get this integral result from this inequality here. Okay, and then the solution is just multiply by sine across sine x, and then you integrate. Okay, yeah. So this is how, yeah, this is one technique you need to learn. So when we like right here, hence that something. So meaning this is implied by directly the thing before it. Okay. It's not come from something else. Must be something before it. That's why we will say hence that. Okay. Yeah. Mm. Okay. Any other question or not when you read this question here? Question one here. No? Mm. Mm. Yeah. Okay. Polynomial. How about you mean this polynomial here? Mm-hmm. Uh, where does the no? It's usually when we talk about polynomial, it's real in real. So one notation we will write is like fx. Fx is in a set, which is this. We call this a polynomial ring. So all these polynomial are power of x. Okay, and then coefficient live in R. 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 Usually is R. If we don't mention anything about coefficient, usually it's in R. Mm-hmm. Why do you want it to be Z or in rational or yeah, 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 correct, correct, yes. So there's one part of it asking the coefficient of derivative whether it is a integer, right? Yeah, it's not always true. Not always true. Not always true. It's just because the way we define f. Let me see. Yeah, the way we define f. The way we define this f here. This is a special f. Okay. Okay, I think I know what your question is. So part A, right, is any f, f be any polynomial. But starting from part B, we look at a specific f here. Okay, and then you are proving stuff for this specific f, not the original f. Okay, but original f satisfy this this equality here. Okay, that's why for this f you also can use. This is a specific f. Can you get it or not? So okay, let me write. So the part A one is the general f. Any polynomial. Okay, for any polynomial. And then when we try to start the proof, part B is a specific f. So maybe I can write fx defined to be this polynomial here. Okay. Yeah. Yeah. Correct. Mm. So I mean, since it is true for general f, so this specific x should also have the same property. Correct. Correct. Yeah. Okay. So I mean, so in the end, you see that this specific f here actually live in no, not specific f. It's just the derivative. Evaluated derivative is in the integer. That's all. Hmm. I mean, yeah. I mean, if it is not at zero, I think the coefficient not all in integer, right? Let's say you substitute one. Hmm. Is it in integer or not? Maybe not. I mean, if you consider fi1 or what, right? No, I mean, okay. Have you checked that all the integer is integer or not? Have you checked it? No, I mean part D you just show for fi0, right? Yeah. Do you know for all other coefficients are integer or not? Hmm? Do you know what I'm talking about? No. Okay, so part D, right? Part D you check the fi0 sorry, fi0. One of the fi0 is non-zero, right? And then you check that that's the integer. There's some integer. Correct or not? Then my question is, do you know the other coefficient or not? Whether they are integer or not? You check? Don't understand. Okay. So I mean, have you checked that this fx here have all the coefficient in z? Yeah. Have you checked that? No. Okay, huh? Yeah. You can try and check. Because every terms here you need to divide by k factorial. So I don't think everything will be divisible by this number. Yeah. You can try check. I don't think all the coefficient can be divisible like k factorial. Okay, one last thing I want to talk about this question is part E. So some of you just show f pi x minus x equals to fx, then you are done. Okay. You need to explain how you get this contradiction here. Okay. So I mean, when you do this assignment, right, make sure you convince yourself first. Okay. So when you read this contradiction, do you know why is it a contradiction? If you don't know, then you need to try and figure out why is it a contradiction. Okay. So in this question here, why is it a contradiction? Okay. So where's the contradiction here? So you first show that f is a periodic function. Okay, f is a periodic function. And then what? Then how does this imply that f, the I derivative of f at pi is also integer? Okay, so you see this is hence that, right? Hence that. So it must be follow from the previous point here. Okay, so you need to think of a way to deduce the ith derivative from this equation here. Okay, what can you do? You just integrate, not integrate, differentiate I time. Okay, and then evaluate at x equals to 0. Why? Because you know about I derivative at 0 from part D. Okay, so you deduce from that fi pi is also an integer. Okay, so D and then implies E. Okay, and then therefore gx is defined in A. If the gx is defined in A, then g prime plus g0 is also an integer. What happened? So where is A? So g is the derivative of this f here. Let's see. That's good. So because you know that fi prime pi is integer for all I. Okay. What is our g? G are defined using the derivative. Okay. So addition of or multiplication of addition or subtraction of I derivative. So you still get integer. Okay. But you also show that g pi plus g0 is in between 0 and 1. Okay, strictly in between from part B. So is there any integer in between 0 and 1 or not? No. There's no contradiction. Okay. Yeah. So I mean, so the clever thing about this proof is to come up with this f. Yeah, how to come up with this f here. So analysis is like this one. So analysis proof of for analysis is like you need to construct some function that works. Okay. For calculus, you need to construct some function that works. Okay. Any function that you construct, as long as it works, then you can use it. This is the proof for analysis. Okay. Yeah. Later I will show you example. Your class come up with a nice example. Part 2, question 2. This is to find. This is to justify why we define the Forest coefficient in the way in the lecture notes. Okay. So if let's say you know that your f is in terms of this periodic function, then you do the integration in the lecture notes, then it will give you the coefficient. So this already assume that my f can be break down using the trigger function. Okay, yeah. This one I think so far most of you okay. Most of you okay. Question 3. Okay, question 3 here. So this question asks you to prove that if a differentiable function is decreasing, then the restriction of f also decreasing. Okay. Why I put this question, right? Remember in the class, when we want to show the sequence decrease, we show that the real function decrease. Okay. And one way to do it is to find the derivative of the real function. Okay. Why does this imply that our sequence decrease? Okay. This is what this question is asking. Okay. If you can show the real function decrease, then the sequence given by this real function also decrease. Okay. So even though we didn't go deep into mean value theorem, I just give you the hint, okay, and then see if you can recognize this fact here you can use. By the way, I changed the strictly less than sign to less than or equal, but this doesn't affect the proof. I changed the question as well. Okay, I just realized that I put strictly decreasing. No wonder that day Jingsen keep asking me, isn't strictly decreasing, strictly decreasing. Remember? Yeah. So yeah, I mean decreasing, but I put strictly decreasing in the explanation or the definition. But it's okay, doesn't matter. Okay. But I want to say that this result hold for decreasing, not just strictly decreasing. Okay. I put an equal sign on. Okay, so the second part of this is the converse true. Okay, let's say you know, okay, you know at integer point, okay, you know that at integer point, okay, you know that at integer point, okay, it is decreasing. Do you know the original function is increasing or decreasing? Okay, does it follow that the real function that connect these dots are decreasing? Okay. So the answer is no. Okay, the answer is no. Okay, you're not necessarily that you need to pick this function, right? Okay, you can do something weird, right? You can do something weird, for example, like this, right? For example, so I accept you to draw it. Okay, just justify why is it continuous, why is it differentiable. I'll give you a point if you just draw it. Okay. So one example I give is this one. I make this dot as the bottom point of my cost function. Okay, this is what I constructed. I write down this formula here. So I don't come up with this formula first. I come up with the picture first. And then I try and write down this formula. Okay, yeah. Some of you actually do similar thing. But what you do is you take modulus. Okay, so the problem of taking modulus, right? You need to take care about the differentiability. Okay, because you should know that. What should you know? You should know that the modulus function is not differentiable. This is not differentiable. Why is it not differentiable? Not differentiable at 0. Why? If you compute the derivative from the right, you get +1. If you differentiate from the left, you will get -1. Okay, so the derivative is not continuous. So derivative is not continuous. So it's not differentiable at the cups. Okay, we call this cups. Not differentiable. Okay, this point is not differentiable. Okay, yeah. So I think I got your picture here. You wrote down this function here. I help you draw the picture. This is the picture. Yeah. So there's the cups here. Okay, those points are not differentiable. So in the question, you need differentiable function which is decreasing, so that you can use the mean value theorem. So that you can use it. Okay. Yeah. Mean value theorems need differentiability. F prime C. And then most of you don't care about where the C is. It's just there exists a C. Actually, that C is very special. That C exists in the interval, within the interval. And not from random interval. It's the interval that you're looking at. And that's C. Remember last time I talked about this C here? All right. So what's the picture? What's the So let me create a new. Remember I talked about this mean value theorems here. Okay. So if you take any point, okay, here M maybe, here N. Okay. So you join a line here. Okay, you join a line. Okay. This line here is realized by some other line. Okay, within the interval. Okay. Which is, for example, let me down a bit, which is, for example, this point. Okay, this C is in between M and N. Okay. Hey, why today so tired? Huh? Stomachache. What you eat wrong? Don't know. Huh? Too tired. Why so tired? What? 6点才睡. Make sure you sleep, take enough sleep. Okay. Yeah. Okay. Surprisingly, when I construct this function, right, this sequence actually come out from a series. Yeah, 11 minus a series of 2 here. This one is out of my surprise one. When I try to compute what are these points here, actually is coming out from a series 2 to the power n. Yeah. If I try and take this bottom point of my cost function here, actually coming from the series. Yeah. You don't need to construct this complicated example. Actually, there's one good example from what's your name? Let me check. Let me check. 左金. Yeah. And it's this example very simple. It's very simple. This example here. This example is cubic. The cubic with double root at one, and then the other root you can just see any root. So the trick here is to make this a cubic increase. Yeah, the cubic increase here. How long did you spend to think about this? Not so long. Yeah, very intuitive this one. Yeah, this one very intuitive. Yeah, this one very intuitive. Mm. Yeah, this one very intuitive. Cubic. So you just make the cubic increase in the natural range, section of the range. That's all. Harder, let it decrease, never mind. As long as I got 1 point, it's increasing. Not just 1 point, there's an interval of point. Okay, yeah. Yeah, and then this one is a polynomial also. Definitely differentiable. Okay. Yeah, very good. Very good example, this one. Yeah. Very good example. And then I think this one from Chen Jie, is it? Yeah, from Chen Jie. One problem about this, your solution is whether, how about the next one? Should I do the same or should I go lower? Yeah, so you need to, because from this pattern, right, I cannot see whether it's going lower or not. Unless maybe you draw like this. Then I know it's going lower. But you see, all here are the same. So I was tempted to think just like this. Then in this case, the sequence is not decreasing. Right. So you need to do like this. Okay. Yeah. So you need to tell people the pattern. Okay. People cannot read your mind. So you need to tell people. But I give you point. Did I give you point? I didn't take half your point, right? Okay, yeah. Good. Okay, this is about question 3. Question 4, most of you okay. Most of you okay. Just about the area stuff. Okay. This area here is a bit tricky. Okay. When you want to integrate from left to right, okay, the time in reverse. Okay, so you need to take reverse time. Okay, from 1 to -1 instead of -1 to 1. Okay. Because the orientation we teach in class is from left to right. Okay, but this curve here go from right to left. Okay, so you change the time interval. Okay, you change the time interval. Also, what I mean here is, so this curve I think is like this, and then here is t equals to 1, here is t equals to -1. Okay, so instead you need to go from 1 to -1. Is it correct? Let me see. Okay, actually this is 0. So here is 0. Some of you just take time from here, -1. Okay. I think it works. It works. Just that you need to explain why you take a different direction of time. Okay, is to match up the normal integration from left to right. Okay, from left to right. But the curve is from right to left. Okay, and then maybe you will ask another question. Actually, in class we didn't tell you how to integrate the bottom part here. Okay, actually this question here you can reduce everything to the top. Okay, but I realize that there's a symmetry at the top and bottom. Okay. Do you know how to realize this symmetry or not? Top and bottom is the same area. Do you know how to realize this symmetry? How to describe this symmetry? How to describe the symmetry along this y equals 0? Mathematically. How do you tell from the formula? F negative C equals F. The X coordinate. Oh, okay, yeah. So you check that at this range here, the Y value is the same. Okay, X value is the same, and then Y is equals, okay, Y, okay, at the same X, you get Y and minus Y. Okay, at the same X, you get Y and minus Y. Yeah, no. Yeah. So what's the X here? Here is 0 to 1, right? Okay. You check that for X in 0 to 1. Okay. And then you can check what? You can check that at what time they reach this point here, 0 and 1. Okay. And then you sub into, there are two values of T, right? Okay. So you pick one X here. Okay, let me write down here. So you pick one X. Okay. There's two times that realize this X here. Okay. And then you sub T1, T2 into Y. And then you should get Y or negative Y. Okay. Then it's symmetry. Yeah. No? Okay. The two times you get for T, the two times you get for X will give you Y or negative Y. That's all. Okay. Or you can write down the formula for this curve here. Write down the formula for this curve. Do you know how to do that? So x equals to 1 plus t squared, right? What? 1 minus t squared, and then y equals to t minus t cubed. Okay. Is there an obvious way to sub them? Is it hard for this question here? Huh? Y equals to tx. Okay, correct. Yes, correct. So t equals to tx, and then y equals to tx, and then what do you do? Okay, x equals to 1 minus t squared. 1 minus x. Okay. And then, but there are two t, right? 2t here. How to substitute? Substitute which one? You mean I get two? Okay, I think I know. Okay, wait first. I'll wait first. So let's say we substitute both of them. Right. So how to do? So there are two answers here, two pieces. Right, two pieces. We can square it. Okay. So since our point is true for this point, it is also true when we square it. Okay, so this also implies that we can y squared equals to 1 minus x and x squared. Okay, so meaning all these points here will satisfy this equation. Okay. So when our x is in between where 0 and 1, right? In between 0 and 1. Okay. So let's check when our point is at 0 and 1. Okay. Is it true that you have 2y or no? You see it? Yeah. Okay. So for all the points here, if you sub here, you can see that you have two solutions. And then these two solutions are minus of each other. Minus of each other. Why? Because this is how we computed here. Minus of each other. When you want to solve for y, exactly these are minus of each other. Okay or not? Okay. So from here, already we can see that y is minus of each other when we get sub the x here in. Okay or not? You see, plus minus the same number here. Correct or not? If you put, for example, x is 0, plus minus 0. Okay, this one nothing to say. Maybe 0.5. You sub into this formula here. Square root 0.5 times 0.5 plus minus. Okay. Okay. But my point here is to see the symmetry from the curve. Okay, see the symmetry from the curve. Okay, so I mean, maybe you cannot directly see from the curve, but when you try and graph it, maybe you guess, okay, what kind of symmetry it has, and then try and prove it. It has the symmetry. Okay, this is the idea. Okay, yeah, you guess and then you prove it. Yeah, question. What do you mean negative? From here to negative Spanish. Negative infinity to 0. You mean negative infinity to 0, is it? To 1 or to 1. I mean, we already know that symmetry at 0 until 0, right? So we just need to see whether it is symmetric at negative infinity to 0. Correct? Yeah, how about negative infinity to 0? It's still the same. It's still the same. Yeah, it's still the same. Yeah, part negative x. Yeah, it's still the same. Because of this formula here. This is the formula. Y equals to plus minus the. So if x is fixed here, if the x already fixed 1x, then the square root times that x is a number. Y is equal to plus minus that number. Okay. So at each x, you have 2 plus. Okay, let's call this b, okay? Because this is a bit long. Plus minus b. Okay, this b is depending on x. If you fix 1x, your b just give you one number. And then y is plus minus that number. So meaning what? So it is also symmetric if you just extend this curve here. Okay, so it just as if you just extend, they are just symmetric. Okay, so you got y here, and then you got minus y. Okay. Any question on Roland? Question? Confused or not? A bit confused. Never mind, just say confused, just say. Yeah, it's okay one. We respect everyone's voice. Okay. Yeah. Yeah. Okay. This question, this symmetric part also bring down to this part 5 here. Okay. Okay, part 5. I really want you to learn one thing. Please learn how to plot using the R theta graph. Don't plot every point out. Remember the story I told you last time? Don't use Pascal triangle to tell me the coefficient. Plotting the point is almost the same as doing the Pascal thing. Right. You need to compute every point. Okay, please use the graph, R theta graph. Okay, and then transfer to this graph here. Okay. Okay, please learn exam. I don't want you on Thursday you draw a table for me. Okay, please learn the R theta plot. Okay, I know that they're quite fast, but please learn. Okay, the R theta plot. And then actually you guys are quite clever, you guys. Quite a few of you, not just one of you. You use symmetry to compute this area here. Okay, so meaning you split, for example, the bigger one you split into half. Okay. And then for the least one you split until 4. And maybe you guys can refer to Jin's answer. His explanation is quite complete. Yeah. He talked about R and minus R, and then theta and minus theta. Yeah, his answer is quite complete. You can refer to this. If not, I just integrate all of the 0 to 2 pi. And then one thing you need to note this formula here. This formula need an R square. How few of you don't use R square? I just use R. So you got wrong answer. You know where the R square come from? Why you integrate R square instead of R? Where's the R square coming from? Of course, theorem. So why theorem got R square? Area of sector or area of circle. Circle need pi R square. Okay, so it's from circle. Need R square. Don't forget R square, not just R. Okay, and then the half there is because you're taking portion of it. Okay. Yeah, yeah. Half. And then other stuff is just integration. Yeah. Okay. Okay. Any question about this assignment? Yeah. Actually, quite a few. Actually, all of you improved from last assignment. Okay. I hope you can keep improving. Okay, keep improving. So the average go from 34 to 39 this time. Yeah, quite good. So keep improving. Okay. Read my question compared to your read my solution compared to your solution. What I want. Okay, what you don't have. Okay, next time put it back. Put it in. Okay, no. Make sure you know my solution. If you don't understand my solution, you can come and ask me. Okay, so that you know what I want, what you need to know. Okay. Otherwise, you just use your own method to study. You won't get it. It's very hard. You won't get it. Okay, no. Yeah. Yeah, your class is very good. I think so the high scorer this time we got like 47, 48, 49. So Jing is the highest one this time. And then I think we still have Larry. And then because I didn't update my drive, so I cannot check my score. It's in my other computer. And then one more, I think one more I remember is Chao Tong. Chao Tong, is it Chao Tong, right? What did you get? 47? What did you get for this assignment? Let me can down. Yeah, I think she get 47. Yeah. And then one more 47, I forget who is it. I remember Chao Tong. Zhongyi get how many? 45. 45. Okay. I think one more 47, I forget who is it. Because my list is not here. Result. Yeah, very good. Keep improving, keep improving. Okay. Yeah, for those who don't perform well, right? Come to me if you need help. Either you don't understand the lecture, either you don't understand what I say, what I wrote. Okay. Very important is the communication between me and you. Yeah, otherwise, if you don't want to communicate with me, then it's very hard. Okay. Yeah. Okay. Yeah. So before we go to the next topic, uh, we will take a break. But before taking a break, let's have some motivation for exam. What kind of motivation you want? I don't know. You don't know. So how far you have you guys finished your cheat sheet yet? Any one of you? Not yet. Start already or not? Start already? Start. Okay, yeah. Okay, got some of you coming out already. Okay. Why start? How start? You can ask me if you start. Okay. Sydney and Roshan, how do you find the content assignment? I have no idea. Very hard. Hard or not? You get start? You guys get start? All the time or do you need help or not? Mommy? Yeah. Sorry, yeah. Yeah, really. You just focus on how to find the Fourier series and how to find Fourier transform. That's all. Which one? I forget which one. I probably read this one. This question here. This one, yeah. Okay. Yeah, it's formula. Yeah, it's formula. You know how should you imagine about this question here? You know how should you imagine about this question? Yeah, how you imagine? And when you do this question, right, you should have a picture in your mind. Okay, not just number. You need to have a picture. Okay, what picture you need to have here? Not really the real picture, but you need to have a path. Okay, what's the path here? Okay, what's the path here? So you have a f here, fx. Okay, here means what? Fx can be written in this form. Fx. Okay, and then let's say here got A, B, C, right? We pick one and discuss. Maybe pick A. Okay, A here says what? An equals to this thing, this integral here. Okay, so what does it mean? Here is f. Okay, here is f. This thing here is f. Okay, you need to integrate f times this number here, this function. I mean, okay. So you need to plug this f here. Okay. Okay. So meaning what? You multiply this cos at every place. Okay, but there's one confusion, one possible confusion here. Is this cos? Okay. There's one possible confusion is this cos. Where's the confusion? The confusion is this n. Why there's an n here? There's an n here. Is it the same n or not? No. Okay, it's not the same n. Okay, so the n here, okay, follows the an. Okay, it follows an here. And then this n come from where? Okay, when you study mathematics book, right, you need to study like this. If we want to ask about this n, you need to go a bit forward, a bit backward. Okay, backward in time. So you go backward in time here. Here tells you what is n. Okay, n is picking from 1, 2, 3. Okay, so meaning a1 equals to the integral fx times cos pi x over l. a2 fx cos 2 pi x over l. a3 fx cos 3 pi x over l. Like that. Okay. And then how about this n? So you ask, how about this n here? How about this n? This n coming from where? So you need to look a bit backward, right? So a bit backward is just here. This sign of sum. There's an n here. Okay. So this n here is indexing by this infinite sum here. Okay. If you don't like, I can change this to I. Same. Okay, doesn't change my function here. Okay. If I change this n to I, then I should change the indexing variable to x as well, to I as well. Where's my laser? Yeah, to my I as well. Okay. Okay. Now. So what do I mean by you need to have a right picture? So you can rewrite this sum, right? You can rewrite the sum like this. X over L plus B1 sine pi x over L plus A2 cos 2 pi x over L plus B2 cos sine 2 pi x over, and so on. Okay. Then you multiply cos to every place. Okay. And then you do it for every n. You do it for every n. Okay. So for example, this n is 3. Okay. Whatever this n is 3. Okay. And then you multiply cos 3 pi x L on every places. Okay. And then you integrate. So Seng should ask, if I integrate this infinite sum, how to integrate? How to integrate? Because this function converges, okay, converges to some fx. So you can integrate term by term. I use theory. Okay. When you integrate term by term, what happens? They are product of cos or product of cosine. So product of cosine integrate over the period by the special case is just 0. Product of cos is 0 also during m and n is different. Okay, so the only term that survives is an. Okay, when m equals to n, or when I equals to n in this case. Okay. And then what's that integral give you? Integral over cos square, you get m by the special case. Yeah. Yeah. I think part of the difficulty of doing this question is to understand the notation. Once you don't understand the notation, you are already halfway there. Once you know the definition, you're also halfway there. So you're almost there already, if you know these two things. Okay. Yeah. So I mean, yeah, you can ask question. Once you get the assignment, if you have question before due, then you can ask in the class. We can discuss. Okay. How to read the question. Okay. Yeah. You do a little bit of research, and then you can come and ask. Okay. You don't need to do everything yourself. Okay. Yeah. Yeah, because my assignment is quite hardcore, so you can ask me question in the lecture. Yeah, hardcore. In my class, I only give hardcore one. I won't give easy stuff. Otherwise, not worth not worth for money. Your money, not my money. You pay or not? You pay. You pay. Okay. Yeah. My class is hardcore. That's all. What is hardcore? What is hardcore? Okay, let's take a break until 12:14. More like one time. Oh, for Muji. Yes.
approval because 要 expire 了。地伙伴，
谁的？
啊？
啊，对的。哦，你呢？
我被我人家送嘛，
我不用。
这个是，哇，你是死的，那你尴尬的也是，处理完，因为assignment也是有出过样子，对不对？可以把完全就把这个考这个放在外面，先看有里面那些，对不对？
啊呀，对，通常是不可以，就是如果 finite 的话可以，finite 可以，但是 infinite 就要 convert 才可以。
我们会吹可以，所以我要讲 conversion。
比如说这题 convert 是因为你就可以这样做。比如说我刚才这个也可以，这虽然是 infinite term，但是它 equal to 一些 effect，convert 去一个 effect 也是可以，convert 才可以，不 convert 不。
那个什么，讲这个是一个 finite 上网，对。
你还不错哎，你几天吧可以写到这样完成。
啊，要死的头发要掉光光，
好厉害哦，几乎满了。
我全部错在广标那边。反正你讲好finite上，但是也是可以，但是你把那个 G 跟那个
就是要 finite 才可以交换，不 finite 不可以交换。
你题目定义也是个 Gx 会等于 fx，
对，
要 infinite。
但是，等下我
你
看
把它换过来，它不就是，但是讲他们都一样的话，就两个 infinite 差不多一样的话，
因为这个是 infinite，这个 definition 是 infinite，但是呢，如果你真的把一个 polynomial plug 进来，不是这个东西只是一个 finite 的东西。
但是我这个写过来这边，我这个整个 infinite 写过来，对吗？
这个整个 infinite，所以它的意思是这样，这个整个 infinite 其实是 finite 的东西，
finite 东西，
因为你想一下，你是 polynomial 就是说它就是
也
一个 finite power of x linear combination of power of x，然后这个东西你 differentiate 几次会不见，你只要 differentiate 到它最高的那个 polynomial 就开始不见了，对不对？比如说你 differentiate s square 要几次，2次它就不见了。
但是我还是不是很理解，为什么你讲的是 finite，
这句话明白吗？Since f is polynomial, all but finitely above are identical, so there's no convergence problem。懂这句话在讲吗？
哦，我懂了
啊，
也就是
嗯，
因为它是 finite，我们就不用查它是不是 convert
对呀，
就不需
对呀，对呀。
要去
然后你这边写什么？
写它是 infinite 的，
结果你写还是 infinite。
因为我以为它是 infinite，我还没有那个概念，就是讲呃概念就是讲
嗯
要讲让我想一下，
嗯
我没有概念，就是 polynomial 是
嗯
一定是 finite。
嗯嗯，
如果它是一个
会有一个最高的 power 在，
那个，如果它不是，如果它没有，就是
那就不能了。
这样就不是 polynomial，是吗？
嗯嗯，那个就是 series 哦，那就是我们学的 series 哦，power series，
Yes，
那个就是 power series 啊。我水壶。
两个，但是我拿每个地
第一张是从哪里下来？
按了就是一样的origin，就是找它 area，
左到右还是右到左？
anti-clockwise， 因为它
对，
是
我们学的是 clockwise 嘛，对不对
课堂上学的是好像
？clockwise，
像它是看上面嘛，就是
对，上面的，然后是 left to right，对不对？
对，但是
Yeah
就是为什么会注意啊？问题是
什么东西会对你？
就是
哦，就是我在班上讲，我 skip 掉这个东西，就是说，如果你换 orientation 的话，你拿到哪个答案？
对的，就是 嗯，
呀，要不什么？
我是这样子，在课堂上它是会记得啊，但是是也是一样可以也从一到简，就是 assignment solution 上面嘛，
对，
但是如果让我们一起拿也是可以的，
啊，一起拿也是可以啊。然后
是为什么可以一起？
为什么可以一起拿啊？
对啊，
因为因为你一起拿的时候，其实跟你分开拿是一样的，就是说你减一到零，零到一和减一到一是同一个东西，在这个情况，
但是比如说我们
在这个情况，因为你减一到零就是下面这个啊，然后零到减一是上面的。
找 A 的找上面那部分，然后我们再算下面那部分，这样它会很显示。
啊，不会，你知道为什么吗？因为如果你算 below axis 的 function 呢，你就是算area above
前面
啊，
有哪个 pen
没有。你这个 iPad 不是可以画吗？
可以，但是我们在那笔，
哦，你没有带笔
可以这样。
啊？
算是一点，
嗯哼，
不是算是一个，我们不要根据好那个，因为它单是这样走嘛。
yeah，
如果我们是好像是减一，然后或零一嘛，然后我们这个
嗯哼，
上面的部分是一，下面的部分是
嗯哼，
这样算，然后我感觉会出那个，就是会变成零是吗？然后两个加起来，
啊，因为 OK，我知道你讲，因为因为你的这个方向是 consistent 的，如果你算这个方向过来啊，跟这个方向他们会 cancel，这两个方向你算起来会 cancel，因为这个方向是 consistent 的，就是它是 clockwise，如果你上面是 clockwise，下面anti，如果你上面是 anti clockwise，下面 anti clockwise，他们会 consistent，他们会 add up，但是如果你上面是 OK，不用讲这两个，其实讲这两个就好，这样子跟这样子会 cancel 啊，如果他们是 symmetry 的话。如果你这样子过来跟这样子过去，他们会 cancel。但是如果你下面也是这个方向，哎，sorry 啊，讲错。所以如果下面是这个方向跟这个方向，他们会 cancel。但是如果他们是会连接的方向，它就会 add up。这个就是我说你可以去 Adam 看的东西，他就是在讲这个东西。嗯，如果 symmetry 的话，如果它顺的话，它就会 add up；如果它同一个方向，它就 cancel。
OK，那我讲了，
嗯，
所以我们好像是 integrate 的时候，我们要根据它的那个时间呢，就是好像减一到一。这样的话，我是更好哪个地方？
不是跟时间，是跟这个 direction。你看，如果跟时间，你是往这边嘛？如果
这个方向啊，就不难。
你是 你是 anti clockwise，但是我要 clockwise，我要 clockwise，对不对？在上课讲是 clockwise，所以你要换它的时间，换从1到减1了。但是刚才已经讲过了，我们没有教过下面嘛，所以你能不能全部变成上面来算？其实要用 symmetry 来考虑。但是如果你要用也是可以啦，我就说你要 refer 去这本。
不然就是如果像我这样上，
对，
因为我的这的话，这样的话我要重新上过，是不是？
你没有重新算过，你的差别只是换一个 sign 罢了。你只要换了一个 sign，这个减就帮你 cancel 掉。然后为什么
这样我们
为什么要换 sign 呢？是因为这个方向的问题。
我记得我可是算了，它好像是有一个就认为还是什么，我不太记得，我会回去找了。
OK，
好像可以直接，好像是他意思叫人可以直接拿我这个写成。
对，就是他可能不看方向哦，但是我要看方向。我们的 area 有方向，
也是有。
对 ，depend on 方向，对。所以如果我一加我就下去，我就不管我在 differentiate 什么integrate 什么东西。对 ，OK，
下面看先啊。
Okay. Sure. Let's start with new material today. Let's start with partial derivative. Okay. We want to start with partial derivative. So yeah, the important thing you need to learn from this course. Yes. Before we talk about partial derivative, right? You know how to get derivative or not? First, like the derivative of one variable, function of one variable. Okay, so let's tell me what you know. Limit h approaches 0, and then
x
plus h minus x over h. Okay.
So it's something like gradient.
So this is the derivative of x. Okay. Do you know how to imagine this gradient? Okay. Okay. Do you know how to explain it in the graph or picture or not? Maybe, yeah. Okay, good. I think you know until this stage is very good. So let's look at this case here. Okay. For example, we look at this x. Let's look at this x here. Okay, gradient here. Okay. So I think you know that your gradient should look like this, right? Okay. Why cannot I draw something like this? Can I draw like this or not? Not small enough, what do you mean? Not small enough. Yeah, how to get this like tangent line? Touch at one point. How to touch at one point? Okay, so I mean, if you try to draw this line, right, if you try to zoom in more and more, you would probably see that, you will probably see that this line will intersect 2 points here. Okay, so here is the extra point. Okay. Okay, so in other words, what do you do? What do you do? Okay, this part is called the secant. Okay, so meaning you look at the x, okay, beside, okay, the point beside your x. Okay, so meaning, for example, let's put this point here, x plus h here. Okay, let's find this point. You look at this, okay, and then you join the fx and fx plus h here. Okay, okay, you look at this secant here. Okay, this is the secant line here. Okay, and then what do? You look at all the hash, taking hash to 0. Okay, so all the hash nearby here. Okay, and then what happened? So you draw more secant. Okay, you draw a lot of secant. Okay, so I think this secant is a bit off. So you draw the secant here, and then you keep drawing the secant. Okay, and then at some point you turn back again. Okay, and then you do more. Okay, and then you finally see that this secant here actually approach the tangent line that you see. Okay, so this is what this limit is doing here. Okay, so that's why we teach limit before derivative. Okay, because derivative is defined using limit. Okay, limit of what? Okay, it's not the fx anymore. It's the difference of fx. Okay, difference of the f beside the point you are interested in. Okay, you want to do differentiation. Okay, okay or not? So you see, so to be differentiable, right? Your limit have to be true from both sides, left and right. Okay, so you should see that the secant from the left also give you the same tangent line. Okay, from left and right, both from left and right. Okay, so this is the idea you need to know so that you really learn your derivative properly. You know. Okay, so what is this limit doing here? This is the secant. Okay, you should have, when I talk about derivative, you should imagine this secant line approaching to this tangent line. Okay, so the blue line here is what we call the tangent line. Okay, so it's the limit of the secant line nearby. Okay, secant line limit to this tangent line. Okay, when x plus h go to. Okay, this is a real derivative. Not x squared become 2x. Okay, this is the derivative. Okay, so x squared, the derivative of x squared 2x is the result of this. That is the result of this thing. Why is it 2x? Why x squared is 2x? Have you imagined before why x squared is 2x? Why the derivative of x squared is 2x? Maybe it's worth telling you this. Then you can imagine later. Can? You can? What does it mean geometrically? So this is fx equals to x squared. Geometrically, what does it mean? Why is it 2x? Okay. So this means what? This means your tangent line, okay, all your tangent line. So you can draw all your tangent line, right? So let's draw the tangent line. So let's draw all these tangent line here. Wait. So you draw this tangent line here. Okay. So this tangent line is a line, right? It has a derivative. I mean, has a gradient. This gradient is coming from the derivative. So for example, let's take points. So here is 0. Here is 1. Here is, for example, 3. Here is, for example, 8. Right, 8. Okay. So what are these y point here? For example, 1, 9, and 16. Okay. So what's the gradient here? Okay. What's the gradient here? Okay. What's the gradient at this point? So you see, at 0, you have the horizontal tangent line. So the gradient here is just 0. Okay. And then at 1, what is the gradient here? 2. Okay. M2 is 2. And then at 3, what's the gradient here? 6. And then at 8, you have 16. Okay. So meaning the gradient of this line follow a function formula, which is 2x. Okay. So that's why when you differentiate x squared, okay, you get 2x. Okay, so the derivative tells you the function of your tangent line, the gradient of your tangent line. Okay, it gives you the gradient of your tangent line. Okay, your gradient of the tangent line follow a function which is 2x. Okay. Okay. So I hope you got a new understanding on this function. Okay, not just decreasing power. Okay, right? Okay, or not? Any question? Okay, so now I want you to imagine. Okay, imagine. Okay, how to go from one variable to two variable? You add another dimension on the domain. Okay, you add another dimension on the domain here. Okay, you need to add extra dimension on the domain. Okay, so you have x and y and z. Okay, so meaning what does it change to taking limit? You can take from different way. Okay, you can take from different direction. Okay, not just left and right. Okay. If limit not found, then yes, that's right. That's from the definition. Yeah, correct. If you want to prove there's not differentiable, that means the limit of the secant doesn't exist. Yeah, limit of the secant. This is the new function you are considering now. Previously, we consider limit of fx, right? But now we consider the function of secant. Okay, so secant. So this difference here is called secant. Okay, so this part here is called a secant function. Okay, yeah. So to check the continuity of f, you check limit of fx. To check the differentiability of f, you check the secant of f. Okay, you check the limit of secant of f. Okay, it's still a limit. So when you do differentiation, it's still a limit. Limit of what? Okay, limit of the secant. Remember this picture here? Okay, tell you how to get the tangent line. Okay, you look at all the secant line that converge to this line. Then this is the line we're looking for. Okay, now. Okay. Okay, so how to go to two variable function of two variable? You add another dimension in your domain. Okay, so once you add another dimension, you see, just now previously you only can go left and right. Okay, but now you can go from front and back. Correct. Okay, you can go from front and back. Okay, you can imagine this y coming up to the screen. Okay, you can go front and back. Okay, so in this case here, this tangent line here live in a 2D place already. 2D place. Okay, previously your line can only lie on a real line. Okay, just one dimensional. When you go to higher dimensional, okay, you can imagine that. Yeah, we have a long loop. Good. Can I borrow? Okay. So previously, right, you can only have either going flat from the right or going flat from the left. But when you add an extra dimension here, you can take the secant like this, coming out from the screen. Okay. So meaning your tangent line also can lie coming out from the screen. Okay. So you take secant in every direction. In every direction. So in here, H here, only from left or right. But in two variable case, you can go from front and back. Okay, like as you can say. So you go front and back, left and right. Okay, so they all converge to a line. Okay, to a line. So this line can be any what? Can be any line on the plane. Okay, sitting on the plane here. Can you imagine? Can you imagine? Okay, let's look at some definition first, and then we will explain a bit more. Okay. Let's look at some example. Definition first, and then we give you Sorry. Okay. So in partial two variable, right? Okay, we can go different direction. Okay, just now we can go different direction. So let me draw some picture. See if it helps or not. Okay. So so let's draw one picture. Okay, I want you to think of a plane first. Okay, think of this plane. Okay, and then imagine you put a heavy ball in the middle of this plane. Okay, so it sink down. Okay, so it sink down. So maybe you can imagine this here. Imagine like this. So you have a plane or cloth. Okay, you put a ball, heavy ball, and then this cloth sink downward. Okay, and then there's a lot of line. There's a lot of secant you can draw, right? Okay, there's a lot of secant you can draw. Can you draw? Just take one point here and the other point nearby from the secant. Okay, and then you can take the limit of the secant here. Imagine or not? Imagine ah. Wait ah. Okay, so let's say I got this cloth here, right? Okay, I put this microphone. And this microphone sync, right? And then how do you draw? For example, I want to take sequence in the middle. Right? How to draw this tangent line? Okay, I can take the ruler just now. Right. I just take the ruler. Okay, I have this plane with me, and then I can draw sequence. Right. And then I draw all the nearby points. Jing San, can you help me hold? So, for example, like this. So you want to check secant here at the middle here, right? So you just take this point here and then connect all the fx nearby, right? Okay, everyone see from here maybe. Okay, let's just say take this point here, this point here, and then I take the nearby fx, okay, this nearby fx, and then converge to the tangent line. And I also can go from the right. But here is 2D, 2D, right? Okay, so I can also take secant from the back to front and then go down. Okay, maybe like this. You can take secant with this point at the point at the back and then come down also. Not just left and right, but I got direction coming in and out. Okay. So you can see that all these lines, right, lies on a plane somewhere. Okay, this plane is what we will call a tangent plane. Okay. Yeah. Any question? No. No. So far, okay. Okay. Thank you. Good. Okay. Okay. Good. So, so what we first do is we fix one direction. Okay, we fix one direction. So let's say we fix x direction. Okay, this x you should think of x-axis and y-axis. So we fix x direction. We want to check the change in x direction. Okay, what do? We fix y. Okay, we don't move y. We only move in x direction. Okay, so this is what we call the partial derivative with respect to x. Okay, we fix the y direction. Okay, we only change in x. Okay, you see, just now x plus h only appear in the x. Okay. So this is called the partial derivative with respect to x. With respect to y, what do? We fix x. Okay, we fix x direction. Okay, and then we plus h and the y direction. Okay, this is to check the change in y direction. Okay. Okay. Question about this differential now. Any question? Yeah. Okay. So this is a partial derivative at AB. So this AB is a fixed point. Okay, it's a fixed point. Okay. And then if I want to look at all points, how? Okay, we just change AB to x1. Okay, we just change AB to x. So if you want to do partial derivative with respect to y x direction, okay, then we just make changes at x. If you want to do partial derivative with respect to y, we just make changes at y. Okay. How to make changes? You just plus h at a different spot. Okay. Okay. And then the formula here is like this. Okay. So you can write f subscript x, okay, or del f del x, okay, or del of function with respect to x, or del z del x, or d1 capital D1f or capital DXF. These are all the same thing. Okay, these are just notation here. Okay. Let's look at one example. Okay. So how to find partial derivative? Okay, let's say you are given a function xy. How to find it? Okay, how to find it? Even though we teach you the definition just now, okay, but we're gonna teach you how to compute it directly, not using this limit here. Okay, this is just a concept for you. But when you go to higher level course, you will need this definition to show. Okay, so what to do? Okay, so to do it in a simple case is easy. Okay, so what do we do? So let's say we have this function fx. So we have function f equals to xy equals to x squared y plus 3y cubed. Okay. And let's say we want to differentiate with respect to x. Okay. So just now we say that we need to keep y constant and then move x, right? Okay. So to compute this without limit, what you do is you see the other variable as a constant. Okay, you see the other variable as a constant, and then only differentiate with respect to x. Okay, so for example here, y is a constant, 3y cubed is also a constant with respect to x. Okay, so if you differentiate this, what do you get? You will just get 2xy. Okay, because 3y cubed is considered as a constant in the direction of x. Okay, it doesn't change with respect to x. Okay, so how about let me test you. What is fy xy? Yes. So what do? You treat other variable than y as a constant. Okay, so x squared is a constant now. So you differentiate xy squared with respect to y. Okay, and then differentiate 3y cubed with respect to y. Okay, and then if you want to compute these two variable, these two partial derivatives at 1, 2, you just substitute. Okay, you just substitute. Okay, for example, fx at 1, 2, you get 4, right? 2 times 1 times 2. Okay, and then for y derivative, you get 1 squared plus 9 times 2 squared. Okay, which is 37. Okay, okay or not? Okay, if okay, let's let you do this question. Let's see if we have the same solution. Try and compute this. Okay, try and compute this. I think one of them is easy, the other one is harder. One of them is easier. Okay. Which one is harder? With respect to x, because it's a product function of product of x. So you need to use product rule. Okay, so what do you get if you use product rule? Sorry, 2x sine xy squared, and then plus s squared y squared y squared. Okay, and then dz dy is 2y x squared cos x squared. Correct or not? We should get x cubed, right? We should get x cubed. Why? Because of the chain rule. Chain rule. Right? Sine xy squared. Right? So you should get extra x out. So you should get s cubed. Okay, yeah. Differentiate xy squared, you will get 2yx. So x times x squared becomes s cubed. Okay. 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 Any question? Okay. Okay, let's continue. So what are we doing here? Okay, just now I show you how we take the secant. So these are special secant. These secants are in the direction of x or y. Okay, if it is fx, it's in direction of x. If it's fy, then it's in the direction of y. Okay, so let's see what happened. What are we actually doing here? Okay, so how we interpret this partial derivative here? So these partial derivative are the slope. Okay, slope of who? Okay, slope of which line? Okay, these are the slope of the tangent to the curve C1, C2 at the point, at a specific point. So let's say, you see, this is our surface here. Okay, so let's say this is our surface. I want to take fx or fy at the point A, B, 0. Okay, A, B, 0. Okay, so we look at this point here. Okay, and then T2 will represent the line with gradient fx or fy. I think it's fy. Okay, fy of A, B, C, and then T1. T2, yeah, correct. Okay, and then T1 is the with gradient fx of A, B, C. Okay. Let's look at one example to show this. Okay. Let's look at one example. Let's look at this example here. Okay. Let's look at this example. F minus x squared minus 2y squared. Okay. Let's compute these two values first, and then later we'll see the graph. So let's differentiate this function with respect to x. What do we get? Very quick. Minus 2x. How about fy? Minus 4y. Okay, let's evaluate this derivative at the point 1, 1. So fx you will get minus 2, fy you get minus 4. Okay, so what does this mean here? Okay, let's look at this graph. We've got this graph here. Okay. So let's look at this graph. So this graph here is x on this side, y on this side, and then z on this side. Is it correct or not? Following the right hand grid rule. Okay, x to y and then z go up. Okay, so this is the right orientation. And then we have this surface here. Okay, the blue part is the surface here. So we are interested at the point 1, 1. Okay, 1, 1. So where is 1, 1? Well, 1, 1 is in this plane here, at the plane here. Okay, and then if you plug 1, 1 into my fxy, what do I get? I get 2. Okay, so sorry, 2, no, 3, sorry. 4 minus 1 minus 2 times 1 is 1. Okay, so we get f of 1, 1 is actually 1. Okay, so that's why we got this 1, 1, 1 point here. Okay, so the height here is actually 1. Okay, and then so we want to look at, for example, this fxy. Okay, so what does this represent here? Okay, what does this represent? Okay, what does this represent? So what we are doing here is actually we are interested in the change in x or y or fx. We are interested in the change in x. Okay, so we want to see in the direction of x how the point change. Okay, but what happened to this direction here? This is the z direction. Okay, this is the extra dimension here. This is the extra dimension here. Okay, so if I have a gradient of -2, right? What's this line? Y equals to -2x. So what's this line looks like? Going from the second quadrant to fourth quadrant. Okay, so this is this line. Okay, so the gradient here is fx. Okay, so how does this line appear on this picture? Can you imagine? How does this line appear in this picture here? See, can you mesh out these two lines or not? How to match these two lines together? This line and this line. Can you match them up? How to match these two lines? How to match these two lines? How is this line? My claim is this is the C1. How do you match these two lines? So here is C1 on the picture. Here is C1 on this plane, X, Y, XZ plane. How to match them two? How to match? How? What? Dot product. No, the product is about vector, right? How to match these two lines together? Yeah, take this arrow and this arrow, glue them together. Take this arrow and this arrow, glue them together. Cannot. Huh? So you take this one, right? You take this plane here, turn it over. Can you imagine or not? Take this, then turn it over. Okay, so what does it mean? What does this mean? This means that you take the SZ plane, okay, cut this surface at the point 1, 1. And then the intersection here will give you the tangent line. Okay, so when you cut it, right? Okay, when you take this, okay, so let me draw another picture. How about this? Okay, let's do this. Okay, I take this plane. Okay, imagine this plane here. Okay, I use this XZ plane, cut my surface at this point here. What should I get? I should get a picture something like this. Something like this. Okay. Okay. And then let's say this point is 1, 1, 1. Okay, this point is 1, 1, 1. So C1 is the tangent line of this curve. So this is C1. Okay or not? So what I do is I use the ZX plane, cut my surface. So two intersection of two surfaces, right? I get a curve. Okay, and then I find the tangent line to this curve here. Okay, now so this is what the partial derivative do. Okay, similarly, if you take partial derivative with respect to y, what do? You take the yz plane, cut at the point that you're interested in, 1, 1, 1, and then you have a curve, and then you get the tangent line. Okay, and then this partial derivative with respect to y give you the gradient of that tangent line. Okay, no? Yeah. Okay. So remember, what are you doing with the partial derivative? You use the zx or zy plane to cut your surface. Intersection of two surfaces give you a curve. Then you can find the tangent line. Okay, and then how to find the tangent line is precisely the partial derivative. You understand? Okay, so let us redraw again to make you more reinforced for your knowledge. So let's do yz plane. Okay, so what's the derivative of fy here? It's -4. It's still second quadrant to the fourth quadrant here. So here the gradient here, let's call this m1, this is m2 of fy11. Okay, so in this case here is easier, right? So if you match up the two arrow here, and then they have the same direction. Okay, yeah. No. See, I take the plane, I go and intersect my surface. Okay, and then I find the tangent. Yeah, no. Okay. Any question on doing this? I think I cannot flip this guy. Can I flip it? I think I can like this. I cannot. I cannot flip it. I think Windows can flip. I don't know. This one cannot flip. Okay. Yeah. Okay. Yeah. I need to flip it. Can you flip? Huh? I cannot flip. I cannot show you this because I cannot flip it. But I can show you this ZY one because ZY is the right orientation. So I just cut it, the surface, and then I find the tangent line. Okay. So why is it not the same? Because I just draw a different slope, so it looks a bit different. But the direction is correct. Okay, so the direction is correct. Okay or not? Okay. Any question about this partial derivative showing using a geometry? So far, okay? Okay. Actually, you should ask a question, right? What question can you ask? Can I take different plane to intersect or not? Right? This one is just zx or zy. Okay, can I use different plane? Maybe, for example, I take y equals to x plane. Right. Do you know what's the y equals to x plane? So okay. So let me draw something. So here is x, here is y, here is z. So far what have we used? So we use this. Okay, so we use zy plane. Okay, and then zx plane. So how should I draw zx plane? So maybe like this. And then they are orthogonal to each other. So maybe I draw like this, orthogonal. So they are orthogonal to each other, like this. Can you imagine what I say? So you have this orthogonal to each other. But in this 2D, 3D space, right, you can take different plane. What do I mean by that? You can take this plane, right, turn the plane around. That's like 360, okay, actually 180 direction of plane you can take, right? Okay. Can you do that or not? You slice your surface with that plane. So intersection of two planes, you get another curve. And then you can get a tangent line as well. Right? Can you imagine? Can you? Yeah, so instead of these two perpendicular plane, I can take different plane. This one agree? Do you agree? We can take different plane. So we can take, for example, this plane. So you see, so for example, here got plane, right? Here got plane. Okay, I can pick this point, this plane here. Right, I can also pick this plane here. Okay, so intersection of two surface will give me different curve. Different curve. Okay, so if I intersect this direction, okay, my curve live in this direction, so I should have a tangent line like this, or up or down, depends. Okay, so what does this tangent line have to do with the tangent line we have just now? Okay. We will gonna study that later. Okay, we will do that in different directions. So we only do x, y for now. Okay, we will do different direction. Let me see. Should we continue this and then take a break? Let's see. Okay, let's take a break here. Okay, let's take a break and then we'll continue. 406 will continue. 506.
那皮下的 area 我还是不是很明白，就是这个是一个 product，
对
下来就是地点这个 R 就是它的这个 Y，
Yeah，
然后这个 θ 就是
没错。
但是为什么我可以在consider这边有个 angle，跟这边的有什么关系哦？只是看起来就是一个 x 嘛，但是这边又有一个 angle。
没有，我想想啊，在做什么？
如果是两个，
哦，没有，这个图活在XY plane
对
XY plane，所以是 XY。 这个只是说我这个 xy plane 的点可以用 r theta 来表示嘛，所以我的 function 我 consider 那些 function 是用 r theta 来表示的 function，你明白吗？
明白。
所以它是活在 xy plane 上面，所以
这个是
这个不是 x，这个不是 r，这个不是 theta，这个是 x，这是 x。
像这个 curve 就不是哦，这个就是在 xy plane 上面的 curve。
对，xy plane 上面，所以那天我不是解释有两种 area 吗？
对，
两种 area，一种 area 是这个 polar 的 area，像那个 pizza 这样，另外一个 area 就是你平时的那个自治的你怎样拿到那个自治，就是你用 x 的时候，你用 rectangular coordinate 来 integrate 的时候，你就拿到那个自治；如果你用 polar coordinate 来 integrate 的话，你就拿到这个。
嗯
嗯，
，OK，
因为你的 polar coordinate 是从0到 r，然后从 angle 两种。所以然后你的 x 是 rectangle 咯，所以 that's why 叫 rectangle，所以你是 integrate 它往这个项目。
OK，
yes yeah。
就走上宣传，你要这样子来回应，这边可以。是的。ไม่ถึงเพราะว่าได้ลงท่า Thank you.
多应该是常规方式。其实，他根本就很其他的应对一表坏死，对。
Okay, I have a better example. So you have this chair. Look at this chair here. Okay, let's look at this point. At this middle point here. Okay, so if you look at this point here, you take this direction. Okay, you intersect it. Okay, at this point, the gradient is like this. Yeah, you intersect it, then you get this point here. So the gradient is like this. But if you pick your plane like this, what can you see? The gradient is constant. Okay, no? So why this chair designed like this? Why this chair designed like this? So why the gradient like this? Because of your bond, your back bond. Okay, your back bond. Your back bond is like this. Okay, but why here to keep constant? You fall down. Okay, right. So this is constant to support you. Okay, and then here support your back bond. Okay, now actually this topic is very good topic for your project. Project 1 or project 2. Both very good, this topic. Very applicable and very theoretical. Okay, so this is the direction. Later we'll see more direction, okay? So this is just one example. Okay, let's do some techniques first, okay? Let's learn implicit differentiation. So this is not far different from what you know, okay? So let's say we want to find dz dx, dz dy, okay, using implicit differentiation. What do I do? Okay, what do I do? What is this? This equation here. This equation here define a surface. I had surface in 3-dimensional. It cut out the surface because you have one variable depend on the other two. Okay, so this one cut out the surface. But why we want to use implicit differentiation? We cannot extract z out. We cannot really extract the z out because there's a z cube here. Okay, we cannot really write z equals to something. Again, cannot. Very hard. Okay. So what do we do? So we just differentiate the equation on both sides. This is what you use in your assignment, right? If two function is the same, then the two derivative is the same. Okay, this is what you use in your assignment. If two function is the same, then two derivative is the same. So how is one a function? One is a constant function. Okay, you can see one as a constant function. Okay, so if you differentiate constant function, you will just get 0 here. Okay, and then how you differentiate this guy? Okay, so one thing you need to note here is this partial derivative, or all the derivatives are linear. Okay, are linear, so you can break them down. Okay, you can break them down into some. So you can break down into the x cubed over dx, dy cubed over dx, plus dz cubed over dx, plus d of 6xyz over dx. Okay, all of these 4 points, which term survive? X. Yeah, so which term survive? There are 4 terms here, right? 4 summand here. So which summand survive? So the second one and the third one should disappear, right? Because there's no x on the numerator in the function. Okay, so these two should disappear because you need to treat other variable as constant, other variable than x as a constant. Okay, so the first one you will get 3y squared plus 0 plus what? Wait. So let's put here first. So here we'll have 2x s. Okay, I think something goes wrong here. Okay, so be careful here. So I'm a bit careless here. So what happened to this term here? This term here doesn't seem to have x. Okay, doesn't seem to have x, but the x is hiding inside the z. Okay, what do I mean by that? So you see, there are x, y, and z here, right? Three variables. So who are independent? Who are dependent? Who are independent? Who are dependent? So how do we decide independent or dependent? Okay, there's one hint from there. Okay, there's one hint from there. So let's say I already picked x. Okay, so this one is independent. Okay, and then we still have two choices to make, y and z. Okay, we can fix either y or z. Okay, but we want to study the change in y. So let's pick y as independent as well. Okay, if I already picked these two numbers, you can already solve for z. Okay, so that's why we call this dependent. Okay, yeah. So meaning here, z is a function of xy. Okay, but you cannot write it explicitly. So let me write here explicitly. Not explicitly. Okay, that's why we call this an implicit differentiation. Okay, you cannot write z equals to some x or y. Okay, so what to do? So this z here. So okay, let me move down a little bit. So this term here actually is z depend on x, y cubed over del x. Okay, more precisely, we should write like this. Similarly, the fourth summand here is z depend on x. Okay, so is it more clearer what you need to do now? Okay, so what should you do? Chain rule. Okay, so you should use chain rule here. Okay, so what to do? So you get 3z squared del z over del x. Okay. Okay, and then plus what is this? This one you need to use product rule. Right? You use product rule. So what do you get? You get 6yz. Okay, plus what do you get? 6xy. Del z over del x. Okay, yes. This one method. Okay, equals to 0. Okay or not? So make sure you know where these variable come from. Okay. So if two of them is independent, then you need to set the other as dependent. Okay. Yeah. This one need to be careful. So this z here is hidden. Why not set z equals to xy, zxy? Because we can change. We can change. Okay. We can make x in terms of yz also can. Okay, depend on what the question was. Okay or not? Depend on what the question. Okay, so the question here, since the question here says that z actually have changes in x and y, so that means z is dependent on x and y. Okay, yeah. Okay, so you can try and work out. So like you can try and work out what is del x over del z. del x over del y, okay, and del y over del z, and del y over del x. You can work all these out and then see what's the difference. Then you can try and work all these out. Okay, but we haven't finished yet. So we need to collect all the del z, del s together. Okay, let's collect all the del x, del z together. So what should we do here? So we have 3z squared del z over del x plus 6xy del z over del x, okay, equals to minus of 6yz plus x squared. So I have a bracket here. Okay, and then you just factorize. You get minus 6yz plus 3x squared over 3z squared plus 6x. Okay, and then you can factorize it. I mean, simplify it. Sorry, simplify it. So you get 2yz plus x squared over z squared plus 2x. Okay, so this is del z over del x. Okay, yeah. So similarly, you can try and compute for the other one, del z over del y. Okay. You see, I put so many exercises, right? I really want you to work it out yourself first. Okay. If you cannot work out, just bring it next lecture. Okay. Yeah, just bring it next lecture. Okay or not? Yeah. So we just keep discussing. Do you know what to do for del z over del y? So you just differentiate the equation with respect to y. Okay, and then make sure you do the right chain rule. Okay. Okay. So this answer here should be minus y squared plus 2xz over z squared plus 2x. And you actually shouldn't be surprised, right? Actually, you can guess this answer, you know. You can guess this answer from the equation there. You know how to guess? Sorry? So this function here has a symmetry. Is it seeable? Can you see? This function here has a symmetry. If you swap x and y, you get the same function. Okay, so meaning if you swap x and y you swap, x and y you swap, you get the same function. Okay, so meaning if you differentiate with respect to y, similar calculation will appear. Similar calculation will appear, and then you can see that this is just swapping x and y. This answer here. Okay, so this is when you see symmetry, this has something to do with algebra. Yeah, use algebra to solve analysis question, but don't use in the exam. Don't use in exam. Exclude this calculation. I'm just telling you something extra. Okay, yeah, but it's a way to help you to check answer. Okay. Okay. Next. So we don't stop at one. Okay, first derivative. We can go to second derivative. Okay, we can go to second derivative. So you can differentiate with respect to x. Okay, what's the next direction you can differentiate? Again, 2. Okay, you can differentiate with respect to x and y again. Okay, so in total, you can do 4 kind of direction. You can do xx, you can do xy, you can do yx, you can do yy. Okay, so there are 4 directions. Okay, to consider. In function of one variable, right, you only have one direction. Okay, f prime x. But in function of 2 variables, each time you differentiate, you got 2. You break up into 2 parts. Okay, and second time, you break into 2 parts again. So 2 times 2, you get 4. You learn probability, right? Yeah. So this is all the probability you can get. All the possible cases. Okay. So for example, let's find the 4-second derivative for this function here. Okay. So we want to find fxx, fxy, fyy, and fyx. Okay, so how to read this? How to read this? So our notation is fx with respect to x like this. Okay, fx with respect to y. Okay, so we read the inner variable first. Okay, we read the inner variable first. And then this is equal to fy with respect to y, and then fy with respect to x. Okay, we read the inner variable first. Okay, so all of these have to start from fx or fy. So we do fx or fy first. So let's compute what is fx and fy. Okay, can you quickly say what is fx? Compute what is fx. E to the power y minus 1. Cos x over y. Okay, good. How about fy? Xy. Plus x over y squared. Okay, and then cos x over y, and then plus 2x cubed. Good. Okay, and then let's pick few of them and do. So let's pick. Okay, let's do all of them. It's quite interesting this case. So fxx, what do you get? You differentiate with respect to x again. Okay, but there's only 2 terms will survive here. Okay, the last 2 summand here will survive because the first one there's no x. We treat it as a constant. So fxs I quickly compute is 1 over y squared sine x over y. You can check plus 6xy squared. Okay, you can check. And then fyy, what is it? Xey minus 2x over y cubed cos x over y plus x squared over y4 sine x over y plus 2. Okay, you can check which one is minus. Third one is minus. Differentiate a cos is a minus sign. And then do I differentiate other stuff or not? Because let me see. But there's a minus sign due to the chain rule, right? Is there a minus sign? So okay. So you see, I want to differentiate these terms here, correct? Okay. So what I do is I use product rule. So the first term is by differentiate the right product, right function here. And then the second one is differentiate this. Okay. But by differentiating this, I got minus sign from cos. I also get minus sign from the x over y. Okay. Yeah. So 2 minus sign. So become positive. Okay. Okay, I want you to do experiment. Compute fyx and fxy. Okay, do it. Yeah. fxy and fyx. Do it. So you differentiate fx, okay, with respect to y. Okay. And then you differentiate y with respect to x. So there's a cross. Okay. Try and do it yourself. Differentiate fx with respect to y, and then differentiate y with respect to x. Try and do it. This one is very memorable. Very memorable. Very astonishing. So let me write down what you want to do. So please compute fx with respect to y, and then compute y with respect to x. Okay, I want Ivan to give me fyx later, and then Jinsen give me xy later. Have you computed fxy? Okay, tell me what is fxy. Evan, okay. Yeah, you do fxy, and then Ivan tell me what is fyx. You differentiate fy with respect to x, differentiate fy with respect to x. Okay, and then Jinsen tell me what is fx with respect to y. Because you can just do both. Yx. So you differentiate fy with respect to x. Right? 要不要吃那个肚子痛药fxy. What do you get? E to the power y plus y squared. So y good minus x over y 1 x over square. Others, please check whether this is correct or not. X over y square, and then plus 6 plus 6 x squared y. Is this correct or not?
One is that y.
X over y cube, right? Okay. Have you got fyx already?
Yeah.
It's the same way this one. Okay, it's the same with this one. Okay, it's the same with this one. So you see, fx looks like this. Fy looks like this. But why you differentiate with different direction, they're equal. Okay, you see, different calculation involved, different product rule used. Okay, why are they equal? Okay, so this is actually a theorem. Okay, so if both your mixed derivative, this is what we call mixed derivative, fxy, fyx, are continuous on an open set, then they are equal. Okay, so what do we mean by open set? So you should think of this as interval in R. Okay, in R you only can go right and left, but in the 2D you can go in a direction of a disk. Okay, this is what we call open set. You can imagine the open set as a disk, open disk around the point. So how do we write this down? So let me write this. Okay, so you should think of this open set. I won't give you definition, but I give you how you should imagine this open set. you should think of the open set as an open this around the point. Okay, let's call it AB. Okay, around a point AB. And what are these points? Okay, so these are the point of fixed distance. Okay, from AB. So let's say we fix the distance as a delta. Okay, we fix the distance as delta. Then we will call this ball or this here maybe B of delta. Okay, at AB, for example. Okay, B of delta at A. Okay, so this open set is a generalization of open interval. Okay, open interval. So you should think of it as a generalization of open interval here. So it is a generalization of, let me write here. So open set is a generalization of an open interval. Okay, so let me draw some picture for you. Okay, let me draw some picture. Okay, let's draw some picture here. So on the real line, okay, on the real line, you have, for example, let's say 2. And you have an open interval here, say 1 and 3. Okay, so 2 is in the open interval of 1 and 3. Okay, but in 2D, two-dimensional space, okay, you want to look at all the points around. For example, this is 1, 1. Okay, you want to look at all the points around 1, 1. So what are these points? Okay, so these points are surrounding around the open set. Okay, or this. Okay, you can think of this as a this with a delta, with a radius delta. Okay, B delta center at 1. Okay, doesn't include the boundary. Okay, doesn't include the boundary. So how do I show that it doesn't include boundary? What I do is I just make it total. I don't want to take the boundary. Okay. Okay. So similar to the open interval, I don't take the endpoint. Right here, I don't take the boundary. Okay. Yeah. So this is what we call the open this. Okay, or similar to the open set. Okay. For example, in this case, it's around 1. Open this at 1. Okay, so why is it open? Because we don't take the endpoint. So here we don't take the boundary. Okay, don't take the boundary, don't take the endpoint. Okay, we don't take 1 and 3. We don't take the boundary here. Imagine or not? Okay. But not too important, but yeah. But this is important when you go to topology. For now, yeah. Okay, the boundary is not excluded. That's why it's called open. Because later you will see what is closed. So better get this idea right first. Okay, so when I talk about open set, you should think about open interval. Okay, open interval. What does open interval means? That means you don't include the endpoint. Okay, then open set, you don't include the boundary point. Okay. Yeah. Okay, so the story here is the clearest theorem that says that if your mixed derivative is continuous, then they have to equal. Okay, but you should think this how to prove this theorem here. Derivative is defined using limit. It's not like you doing product rule or what, right? It's using limit. So the double secant limit here have to agree as long as it is continuous. How to prove? How to prove? Actually, it's not too hard. It's just writing down the limit definition. And then you should see that the limit commute. Yeah. You should see the limit commute. Okay. If you differentiate with respect to x, meaning you plus h at x. If you want to differentiate with respect to y, meaning you plus h at y. So somehow the order doesn't matter if it is continuous. Limit outside of limit. Limit outside of limit, right?
So
Why the limit commute?
it's time consuming.
No, it's another theorem that tells you that it can commute. It's the secant function, right? You start with fx first, and then you do it on fy. Okay, sorry. So you have a fx secant function already, right? You take the derivative for fx, and then this function, you want to do a limit again. Imagine you have fx first. Okay, fx is what? Fx is this guy. So fx is this guy here. Yeah, you got this fx. Okay, and then this whole thing become a function again with respect to. Then you want to do this whole function, take a limit with respect to y. You should imagine like there's like something else. Yeah. Yeah, this guy here, this guy here, this guy here, this guy here, this guy here. Exactly this guy, exactly this guy, this guy. So this is fx, right? So you want to do fxy, meaning you need to do this limiting on this fxy. So but this fxy look like this. Okay, so what is, for example, you need to care about fx of x, comma y plus h. What is this? Parallel. And then you want to consider fx of x plus, x comma y plus h minus fx of xy over h of limit h to infinity. So, parallel. This is what we want, f x y. Okay, this is fxy. Okay, but fx here defined in terms of limit again. Okay, so you need to plug this whole thing in here. Yeah. Can you imagine? I don't ask you to compute, but do you know what you need to do? You just need to know what you need to do first, okay, before computing, right? So we want to compute. So we want to compute fx with respect to y. Okay, so that means you need to know what's the function of fx first. But this fx here is defined using limit. Okay, is defined using limit. Okay, so to compute fx with respect to y, what do? You need to see what's the formula here. Fx of a comma b plus h minus fx of ab over h. This. Okay, so you need to change in y direction. Okay. Yeah. So it's a limit over a limit here. Imagine or not? Imagine. You don't need to compute first. You just need to know what you should do first. Any question? Okay. It's also a good project question actually. This one. Yeah. Last semester, someone do this. Someone did this. Not too hard, I think. Yeah. Not too hard. Seem very hard. Again, there's few limits you need to take care, but actually quite straightforward. That's the point where why you need to know fxy and fys is continuous. If they are continuous, then the limit should work. Okay, yeah. Okay, okay, yeah, you can try an experiment, but in proper course, you don't need to prove this. You just need to use it. Okay. So by clearer theorems here, as long as you get one of them, okay, you know that fxy is continuous, then you don't need to compute fys already. Okay, you will sure away get the same answer. Okay, for example, just now. Okay, so just now. Here, our fxy is like this. Okay, but so this guy is not continuous as y equals 0. Okay, at other point they should agree. Okay, this is what it means. Yeah. Okay. Okay, so you don't need to stop at 2 variable. You can go to 3 variable, 4 variable, 5 variable, 6 variable. Okay, and then you can differentiate with 3 direction, 4 direction, 5 direction, 6 direction, z direction. Okay, n direction you can do. For example, in 3 case, you can change in x direction, or you can change in y direction, fix the other 2, or you can change in z direction and fix the other 2. Okay. So if you go to higher level, then you should do n dimensional, n case. Doesn't need to fix at one. You want to try this example, or you want to skip? You want to try, or maybe I just let's test whether we know this or not. For example, we want to find x derivative. Okay, what should we do? We should just treat all the other variable than x as a constant. Okay, and then we differentiate with respect to x. In this case here, we will get y plus 3z. Okay, y plus 3z. Because we treat all the other constant as all the other variable other than x as a constant. Okay, make sense? Okay, maybe we do one more to confirm. How about differentiate with respect to y? What do we get? We get x plus 2z. Okay, so the last summation here disappeared because there's no y here. Okay, so all these are constant with respect to y. So this guy disappeared, and then you differentiate xy with respect to y, I get x. Differentiate 2yz with respect to y. Okay. So speaking of this, maybe you think that this is useless. Okay, this definition is useless. You can challenge yourself. See if you compute the limit, do you get y plus 3z or not? If you use the limit, do you get x plus 2z or not? Okay. Try and compute using this limit here. See that you get the same answer. Okay, you can try and challenge yourself. Okay. Okay. So try and compute what is fz. Okay. So if you can challenge yourself. Get this number. Get the number using. Get the function. Get the derivative using the limit definition. Or I think high school called it the first principle. I think first principle. Yeah. So this is the definition. Yeah. In the high school they call it first principle, but this is actually the real definition of derivative. Okay, it's the idea that I draw to you at the start of the class, looking at the limit of the secant. Okay, this is how they invented this derivative at first. Okay, it's not like differentiate x squared, you get 2x, like get the power down, decrease. No, that one is because of the limit of the secant. Okay, due to the limit of secant. So you see, so this is the part where the maths become beautiful, right? We just try to find limit of secant, and somehow this finding this limit give us another pattern. With, for example, a polynomial with differential polynomial, the power of polynomial decrease. Okay. We differentiate EX. EX still get the same EX, meaning the EX is a function with the derivative having the same function. You get what I mean or not? Okay, I want you to imagine this thing. So you get EX, okay? For example, EX. What is EX? Or EX is something like this. Okay, EX. And then you go and measure the tangent at each point. Okay? And then this MI follows the same function. Okay, this MI follow the same function. Follow the same function. Yes, again. This is the extent of d over dx of EX equals to EX. Okay. If you take the number of your gradient, you still get the same function. You know, you go and check all the tangent line, okay, and then you get the gradient. Go and plot the graph out. Still EX. Differentiate still EX, still EX, still EX. Okay. Okay. For example, another example. Differentiate sine x equals to cos x, right? Okay. So what does this mean? So you go and take your sine graph. You go and take your sine graph. Okay. And then what do? You check all the tangent point. Okay. Somehow this gradient follow the graph of cos x. Okay, how does cos x go like this? Okay, so you see here, sine x when close to origin is approximately x. So the gradient at origin is 1. So you see cos x start at 1. So at this point here, this is a fact that you need to know. Maybe I don't prove to you, but you need to know. At 0, 0, sine x is almost the same as x. Okay, so that means the gradient there is 1. So you see cos x start with 1. And then you can see that this gradient here decrease until you get 0. Okay, how does it decrease? It decreases exactly like the cos. Okay, and then it change direction. So here go to negative, change direction. And then go to 0, go to 0, go to negative 1. Okay, and then go up again. Okay. Yeah. Okay, so I hope you get a different way to see this derivative now. Okay, when you differentiate, what do you see? Actually, you see the changes of this tangent line. Okay, now. See, should we continue? Okay. Okay. Any question? So there are few examples on these derivative. Again, maybe we will do it at the start of the next lecture as the exercise. And before we add any question about exam or lecture, anyone last question? What is the question? You mean the exam question? Exam question, one hint I can give is really similar to a practice exam. So you need to master all the skill inside your practice exam. Okay, how to sketch polar curve, how to find area. How many questions? To find for same. It's the same. 6, 5, and 5. Practice exam only got 5, right? Yeah. Yeah, so okay, before you say, let you say. So I said so One very important thing about the true false question. True, prove it. False, give example. Don't tell me why it is false. Give me counter example. Okay, yeah. Don't prove it wrong. Give counter example. Okay, not. Assignment also a lot of people don't give counter example. Don't tell me why is it wrong. Why possibly wrong? Tell me counter example. Then I will know why is it wrong. Okay. Yeah. Okay. Yeah. Change it. Any double side. Double side. Handwritten. Don't put what sticky note. What don't put. Don't. Just paper. Okay. Just paper. Yes. No sticky note. What? Okay. You know sticky note? Yeah. They put. Take the sticky note. Yeah. Handwritten. Double sided. A4. Don't go A3. A4. Huh? A1 is big or small?
Big. I don't know. I got bigger. Is it like
Then I flip to A4 and then I. Okay, yeah. A4, A4. Okay, another thing. Okay, please time at least 10 minutes earlier so that we can start on time earlier. I'll give you reading times about up to what time? 1:05. And then maybe we'll take 1:05 up to 1:45. Okay, 1 hour and 40 minutes to finish the exam. Too long. Okay. So one thing is you need to plan your time well. Don't get stuck over one question too long. Okay, skip, and then come back. So my question is like 1 point about 1 minute. Okay, so if you spend more than the time that I give you in the marks, then you need to be careful. You need to adjust your time, okay? Yeah.
If I skip all Christian how to
Hey. No, I mean you skip all and then you come back and do the one that you will have the most confident one first. Okay. So one thing is you don't stop your momentum writing. If once you stop, very hard. Yeah, don't stop writing. And then any more questions before we go? Why? For midterm, this week. Okay. If you have more questions, you just email me, message me. Okay. And then tomorrow I still have an office hour if you like. Yeah. Okay. And then good luck. Please study well. Study hard. Yeah, tomorrow. 10 to 12.
Thursday morning.
Why?
Have class. Yeah, class. Thursday morning also can.
Morning what?
Thursday morning.
You want to meet me?
Yeah.
If you want, we can send out the time if you want. But I'm not sure it will be too tired. We can send out time if you need. Yeah. Oh, you can. Yeah, so see you on Thursday. Please come 10 minutes earlier on Thursday.
10 minutes earlier.
10 minutes earlier. So that we can start on time. 对呀，对有。对呀。
就是本来我觉得挺多的，然后写完之后就写了1页半。
不错。
写的太挤了，自己都看不见写的啥。
然后自己看得见啊。哦，对。